So this is the last problem that was requested. 4.3, question number 5. So this is the problem. Okay. Here it is asking you to find the complex zeros of the polynomial function. But one of the things to identify here is, since I am not given any complex zeros to start with, I will have to go through the same process that I did the other problems, which means I need to start with Descartes' rule and go from there. Okay, so first step, same thing, repetition. I'm listing using Descartes' rule. I'm trying to list the positive real zeros, negative real zeros, and the complex zeros and the total. So I know the total has to be 3 because the degree of the polynomial is 3. So first I'm looking for the sign change, and I'm just seeing just one sign change here. So that is telling me there is one positive real zero possible. Okay. The next thing I'm going to do is go f of negative x. So which is 2 times negative x the whole cubed plus 3 times negative x the whole square plus 8 times negative x minus 5. That's making this a negative 2x cubed plus 3x squared and a minus 8x minus 5. Now I'm looking for the sign changes. So I have 1 and then 2. Therefore, I can have 2 negative zeros. In that case, I will have 0 complex zero. The other option is I'm still going to have 1 positive 0, then 2 minus 2, therefore 0 negative zeros. And in that case, I'll have 2 complex zeros because my degree has to be 3. Okay, so this is one of the options. I will get one of this when I finish my problem. Either it has to, now in this, it's very interesting in this problem, the question itself is asking us to find the complex zeros. So from that, we can make the assumption that, the last category, this will be the answer format, which means I will get one positive real zero, and with the help of that, I will be using synthetic division to break it into a second degree polynomial and then look for the 2 complex zeros. So I'm assuming that it has to be in this category because the question is asking for complex zeros. Okay, but we'll see. We'll work the problem and look at it. Okay, for step number 2, list the potential zeros, which is the factors of the leading coefficient. In this case it's pi, so it's plus or minus 1 plus or minus 5 divided by the factors of the constant term, the constant term divided by the leading coefficient. In this case it's 2, so plus or minus 1 over plus or minus 2. So this is telling me my list is either going to be plus or minus 1 over plus or minus 1, which is plus or minus 1. Okay, so dividing it out, write it. So either it's going to be plus or minus 1 or plus or minus 5 or plus or minus 1 over 2 or plus or minus 5 over 2. So let me list it out. So it should be either plus 1 or minus 1. Again, I'm writing it out just so that I can easily identify where to go. So plus 1 minus 1, plus 5 minus 5, plus 1/2 minus 1/2, plus 5 over 2 minus 5 over 2. Now, one of the things I can see here is since either if it's the first category or the second category, I must have one positive 0 for sure, right? One positive 0. So even if my answer is going to be the first or the second, there should be one positive 0. So that is telling me that one of my answers is in this positive list. among this 4, one of it is going to be my answer. Again, to find that, you can do 2 options. One is you can either do graph it and look for it, or you can do, remainder theorem and look for it. I'm going to graph this polynomial, so I'm going to say 2x to the power of 3 plus 3x squared plus 8x minus 5. Now, since I know that it's going to be positive, one of it's going to be positive, I don't have to worry about my negative side. So I'm going to keep my negative window x minimum as 0 and leave the rest as it is and graph it. Okay, so this is telling me this is one of the 0. Again, I can look for it either going into the second trace 0 option, or I can go into the table and look for it there. When x is 0, that's my y-intercept. I'm looking for my x-intercept, right? So, it should be in the positive side. Again, it's because the table set is starting at -3. So if I start at 3, then I go in increments of thing, let me graph it. How about if I change my window to -5? That'd be a little bit more better. Okay, so in order to look at this, this looks like a decimal value here. So it could be a half in there. So let me see. Second calc 0, I'll use that option. Left bound, so bring your cursor to the left side, go to the right. There it comes. Enter, right bound, enter, enter again. So that is giving, so it's just 0.5. So when x is 0.5, so it's from here I'm figuring out that this is one of the zeros. Okay. Now to cross verify, I can do, or to break it into a next degree polynomial, I can do a synthetic division. So x equals -half is a 0. Okay. So I would go into the polynomial and do synthetic division. So 2, 3, 8 and -5. I'm going to divide this by -1/2. So -1/2 times 2 would be, like, first I bring down the 2, then I go 2 times -1/2 is -1. 3 minus 2 is 2. 2 times -1/2 is -1. 8 minus 1 is 7. 7 times -1/2 is -7/2. So let me check if I wrote it right. 2, 3, 8 and -5. 2 times -1, 2. So something's not working here, right? So let me, oh yeah, I'm sorry, it should be +1/2, not negative. Okay, I'm so sorry. I said x equals 1/2 is a 0, not -1/2. So this should be, where is it? Okay, so if I bring down the 2, 2 times 1/2 is 1, 3 plus 1 is 4, 4 times 1/2 is 2, 8 plus 2 is 10, 10 times 1/2 is 5, therefore is 0. So this is letting me with the polynomial 2x squared plus 4x plus 10 equal to 0. Now again, since factoring is going to work out, I think at least to some extent I'm going to factor it. First I'm going to factor out a 2, which is going to give me x squared plus 2x plus 5 equal to 0. And it's very explicit that I cannot factor this polynomial. So I am going to take this x squared plus 2x plus 5 equal to 0, because if I divide both sides by 2, the 2 will disappear. So now I cannot factor this, so I am using the quadratic formula. Quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac over 2a. Now a in this case is 1. Again, a is 1, b is 2, and c is 5. So if I plug it back in here, I'll have x equals negative 2 plus or minus square root of 4 minus 4 times 8 times 3, 4 times 5 is 20 over 2. So x equals negative 2 plus or minus square root of negative 16 over 2. X is equal to negative 2 plus or minus 4i over 2. Simplified will give me x equals negative 1 plus or minus 2i. If I factor out a 2 from the numerator, I will and cancel it with the denominator, I'll end up with negative 1 plus or minus 2i. Therefore, the answer to this question is, because it's asking for complex answer, x equals negative 1 minus 2i and x equals negative 1 plus 2i. I don't have to list the positive 0 or the real 0, because it's not asking for the real zeros. It's just asking for the complex zeros. I hope you understood.